Many students asked a question that, sir, what's a space-time, and you can also describe space-time in physics, or space-time is an mathematical model, and what's focuses on its three dimension of a space, and what are these things. Okay, so I have take these questions, and I have a detailed video of this to give your knowledge about space-time. Okay, physics, space-time is any mathematical model which focuses the three dimensions of space and one dimension of a time into a single four-dimensional manifold. Okay, space-time diagrams can be used to visualize relativistic effects such as why different observers perceive differently where and when events occur. Okay, and until the 20th century it was assumed that the three-dimensional geometry of the universe, its spatial expression in terms of coordinates, distances and directions, was independent of one-dimensional time. The physicist Albert Einstein had developed the idea of space-time as a part of his theory of relativity. Prior to his pioneering work, scientists had two separate theories to explain physical phenomena. Isaac Newton's The Law of Physics described the motion of massive objects, while James Clerk Maxwell electromagnetic models explain the properties of light. So in 1905, Einstein based her work on special relativity on two postulates. Okay, so are invariant, the identical in all inertial system known as writing frames of inference. The speed of light in a vacuum is the same for all observers regardless of the motion of the light source. The logical consequence of talking these postulate together in the inseparable joining of the four dimensions Harto assumed as independent of the space and time. Okay, and many counterintuitive consequences emerge. In addition to being independent of the motion of the light source, the speed of the light is a constant regardless of the frame of the reference in which it is measured. The distances and even temporal ordering of pairs of events change when measured in different inertial frames of reference. This is the relativity of simulating, and the linear additivity of the velocity no longer holds true. Okay, and Einstein framed his theory in terms of kinematics, the study of moving bodies. His theory was an advanced or Lorentz 1904 theory of electromagnetic phenomena, and Poincare's electrodynamic theory. Although these theories included equations identical to those that Einstein introduced, the Lorentz transformation, they were essentially ad hoc model, is proposed to explain the results of various experiments, including the Franz Michael-Morley interferometer experiment, that were extremely difficult to fit into existing paradigm. Okay, so hopefully this video is helping for you to understand space time. Thank you very much.